Hey there, statisticians. So on Friday, we talked about bar graphs. Yesterday, Monday, I showed you how bar graphs could, or how different graphs and bar graphs can be misleading for our information. So today, let's look at our side-by-side bar graph. Now, this information comes from members of an environmental club, and the percent of club memberships, people that said no, people that said yes, and then a snowmobile use. So this blue bar right here, and you said I am not an environmental club member, and I own a snowmobile. In red, it was I am not a environmental club membership, but I rent a snowmobile. And then in blue, these people are not members and they never rent a snowmobile. And then same over here in the colors. You may want to color yours up. So you may want to hit up some colors on this. You're gonna because on yours it's hard to see who's who. So I'm gonna kind of do. Here's my renters. So you may want to highlight on your page. Let's do orange. These people never ride, just so you can kind of follow along. So now this is what we call a side-by-side bar graph. So you're going to cluster your responses by cluster your bars by response. So all three of these bars said no. All three of these bars said yes. My vertical axis is always going to be a percent. So I don't know the number that said no, but I can break down the numbers individually right here. And if the categories of each response are added together, the sum will always be 100%, because I need to know 100% of the people that said no and 100% of the people that said yes. So like if we're looking at this, this looks like about what, probably about 23%. And then in red, we're looking about 41%. And in blue, we're looking at, let's see, so that'd be 64. So this would have to be about 36%-ish, maybe, because all three of those would add up to 100. Now, I'm not sure if this is what they actually are, and reading them by off the bars can be kind of hard. But if you notice, you add all those values together, I do get 100%. 100% for everybody that says no. So you can see by conclusion that if you're a member of an environmental club, you're much less likely. The data suggests that you're much less likely to rent or own a snowmobile. Many more environmental clubs say no, because that's about 70%. So that's a side-by-side bar graph. You group by response. A segmented bar graph. Now it's one bar for each response. This entire bar was a no. This entire bar was a yes to the question, are you in an environmental club? So categories inside each one are going to be stacked instead of side by side. And then the height of every bar is the same, add up to 100%. But the different categories you can see are their different heights. So, but this is the exact same data as the other bar. So you can see that we've got 36% right here, about 41% right there, and about 23% in that bar. Same as the other one, just stacked, and that's called a segmented bar graph. We also have a mosaic plot. Students were mentioning this earlier. Now notice what's different about a mosaic plot is the widths are different on each bar, because the widths of each bar are proportional to the number of respondents. So the width tells you roughly how many people responded with each outcome. So you can look about 4 times as many people said no to being an environmental club membership as said yes. And then the height of the bar is the different categories for each response. So what we're saying here, let's say yes was 100 respondents. I'm just making this up. 100 respondents said yes. And then that would mean that no was about 400 respondents, because No looks to be about 4 times bigger. Okay, so mosaic plots kind of give you an idea of the number, and then we still have relative frequency going up this way. So many more people said no than said yes. That's what a mosaic plot tells us. All right, so what I need you to realize when we are doing these, drawing our graph is never, ever, ever the end goal for the majority of what we're doing. We use graphs to help us draw conclusions. We use graphs to determine if an association exists between explanatory and response variables. Now, when I say an association, what we really want to avoid is saying the words cause. We don't want to say cause. We like to say there is an association between two variables if knowing the value of one variable helps us predict the value of the other. So if I know the value of one variable, I can predict the value of another variable. If knowing the value of one variable does not help us predict, then there is no association. So like the number of times somebody eats fast food during a week and their overall health. You know, if somebody eats a lot of fast food during the week, their overall health is going to go down. So that would be a negative association. The number of hours that people spend studying their classroom materials and scores on the test, that would be a positive association. The more I study, the better I do on tests. So remember, association or correlation does not mean causation. Just because I study does not cause my score to go up. Generally, that's what happens, but it's not a direct cause and effect. So if you look back at that last those bar graph examples with the environmental clubs and snowmobiles, being in an environmental club may or may not have caused snowmobile use, but it is an association. Environmental club members were less likely to have snowmobile use. So this data does show an association between environmental club membership and snowmobile use. Notice the reason I know this. We have different percentages for each of these responses, each of the sub-responses. Oops, let me get a pen that writes. So we have different percentages we have different percentages for snowmobile use, yes and no. For instance, if I look here, we said this was what, about 36, and you can clearly see this is about 70%. Totally different. There's about twice, this red is about twice as big as this red, and this green is about 4 times smaller than this green. Alrighty, so these percentages are different. That means there is an association. If you say yes, you're more likely to have never used a snowmobile than if you say no. All right, so hey, I know you're in an environmental club. What does that lead me to believe about your snowmobile use? I believe you don't use snowmobiles. Now, no association would show that these bars are exactly the same height. So if I know you're an environmental member, does that let me tell you if you're never or renter or owner of a snowmobile? And the answer is no. These are all the same. Well, we've probably got about 43%, and then from 43 to 80, so that would be about 37%, and then this is 20%, and they're all the same. So if I know you're in that 20%, I don't know if you're a yes or a no. Got it? That means no association. Boom. All right, so let's look at our summaries for the rest of the unit. So remember so go ahead, highlight anything that you need here. Not just what I covered right now, but the entire thing. And if you've got questions, I will gladly answer those when I see you next. So let's go ahead and complete assignment 1.1. and then get those answers into Student View. In Statisticians, I will see you when I see you.